All right, so we're live. Hello everybody, welcome to ONOS TST meeting. Let me open up first that we have a new module owner. Sean Condon was recently nominated, and we've entered a configuration for him to become one of the code reviewers, which is great, because we need all the help we can get and good eyes on a code. And for this week's primary topic, we have Georgios Katsikas. Pardon me if I butchered your name. Who is going to present us an overview of the ONOS provider mechanism to how to effectively get commodity servers configured for NFV using ONOS. So with that, please, Georgios, you can take it and tell us all about it.
Should I start?
Yes, please.
Okay, can you hear me all?
Yes, loud and clear.
So first of all, thank you very much for accepting my proposal to present this idea in front of the ONOS community. My name is Georgios, as you already said, and I'm a PhD student at KTH and RISE 6 in Sweden, Stockholm. And today I'm going to present you some ideas about how to enhance the southbound abstractions in ONOS by incorporating monitoring and reconfiguration capabilities for commodity servers. So let's give first a brief introduction about the motivation of this work. So modern services such as, for example, Facebook, Instagram, and data analytics are highly distributed in nature, and their popularity has forced network operators to reshape the networking paradigm. A classical example is data centers, where there has been tremendous need for elasticity, which is the need to scale according to the workload. And this in turn has been achieved by introducing network and service programmability. So as you can see at the bottom part of this figure, a typical data center network consists of two pieces of fabric. First is the network fabric, which is typically a class-like topology of programmable switches, and secondly, a large pool of servers interconnected via the network fabric. Currently, ONOS provides great abstractions for managing the network part of such an environment. And this is done by supporting both legacy and programmable network elements. However, to the best of my knowledge, there has been a gap in efficiently and effectively managing the server side. And to make things worse, sometimes there seems to be a fact that ONOS is not able to provide drivers for commodity servers. And although I'm not fully aware of the Cord project and the activities in this area, as far as I know, Cord is a use case of ONOS. I haven't seen any implementation of drivers that allow ONOS to interconnect, to talk and communicate with servers. And at the end of my talk, I would also appreciate some insights on Cord and whether some of the problems that I will tackle in this talk are already addressed by Cord. So I believe it's very important for network operators to have a good view of the server's fabric, because very recently there has been a pressure to delegate more and more tasks to those servers. So it's not only about the typical applications that I talked about in the beginning, like Facebook, Instagram, and so on. It's also a new trend, which nowadays is dealing about moving packet processing logic into the servers. And this is, of course, a very well-known network functions virtualization paradigm. So in this context, the packet processing pipelines and the overlay applications needs to exploit additional programmability that is provided by the servers. And some important programmable components in commodity servers are CPUs, memories, graphical processing units, network interface cards, and very recently we have seen also the trend of smart NICs with additional programmability. So I believe that ONOS needs to address this emerging situation by incorporating commodity servers at the southbound interface. So in the next slide, and in this proposal, I will attempt to close this gap by introducing a preliminary means for ONOS to manage programmable resources in commodity servers. But before I discuss how to do this, let's first step back and think how modern servers are actually structured and how they are able to process traffic. The way they do it is quite similar with typical switches, but there are also differences. So let me explain you exactly how it works. So imagine a server like the one that you see in the figure with 4 CPU cores and 2 network cards, and assume that each of these network cards is connected to a different switch. So this server could potentially act as a forwarding device between the 2 switches. So when a packet enters a server, the first thing that happens is that the left-hand side network interface card receives the packet and DMAs this packet to main memory. Next, the DMA operation is followed by an interrupt that is generated to a CPU core that needs to process this packet. And then the CPU executes the application logic that processes this packet. In our example, the application can just be a forwarding application, and eventually outputs the packet out of the server toward the second switch. So this starts questions as to how does the system choose which CPU core to pick the packet and process the packet. So modern systems have several techniques to achieve this functionality, and to name a few, there are dynamic versus static interrupt handling. There is RSS functionality that is done in the NIC and involves hashing to choose what would be the CPU core to process the packet, or some explicit rules that we can install to a NIC in order to explicitly dispatch the packet to a desired CPU core. So once a CPU core receives the packet, there's another fundamental question, and this is which application is going to be used to process the packet? What would be the processing pipeline for this packet? So there can be millions of applications for processing this kind of packet, and because there's such a big diversity, we need to find a solution that allows a controller to be able to manage a server. So if I were a controller and I wanted to find a way to do so, I would like to have an explicit way to transfer packets from a network interface card to a CPU. And an expressive way to do this is by installing explicit rules. The second question that the controller needs to know is, what is the explicit language for processing packet? So how can we structure a pipeline for servers? And because we're talking about general purpose CPUs, this is a quite different task as compared to regular switches, as you can imagine. And the third requirement that we have is what is the way to monitor some key resources in the server such that the controller is aware of the state of the server at any given point in time. So in the rest of this talk, I will try to address these 3 questions with a very specific proposal. And this proposal is not necessarily the best one to address these questions. It is just acting as a motivation for the need to extend ONOS in order to become aware of how to abstract and manage server resources, basically. So to address the first question, our proposal proposes a way to remotely program a network interface card with explicit instructions for dispatching packets to a specific CPU core. To address the second question, I propose to use click as a way to structure the pipeline, the processing pipeline for the packets. And to address the third problem, in the next slide, there is some intuition on how to abstract NIC and CPU card and CPU resources while being able to collect runtime statistics from the system. So let's move to some abstractions. So the current status of the proposed driver covers two pieces of resources, CPUs and network cards. And in the table that you can see in this slide, there is some basic information that CPUs and network cards can expose to a controller. Network cards are particularly interesting in this case because from a management point of view, there are similarities to basically the ports of a regular switch. So just like an OpenFlow port, a network card has its own ID, number, type, MAC address, and so on. And it also allows to install rules that look like OpenFlow rules with match action fields. And the last piece of this table is actually the most important one because it provides a lot of space for contributions here. So in the current prototype, we mostly care about the rules that the controller can install to a NIC, but in order to dispatch packets to a CPU core, but this can be generalized to add more functionality like offloading tasks that can be done by network cards. And if we talk about smart NICs, this is going even further. So in the future, I would really like to work on some extensions of this project to introduce additional features. And as I will explain later, this will also pave the way for future integration with other emerging technologies like smart NICs, as I said before. So regarding abstractions for statistics, we can also implement this kind of functionality in the driver by providing basic statistics for CPUs, such as load information, and for network interface cards, statistics that are very similar to port statistics already existing in ONOS. So now let's proceed to some technical details about this proposal. From this point on, I will talk about how we map basically this idea to the particular architecture of ONOS. And given that there is this driver already exists in the ONOS system, a first key technical question I would like to highlight here is what protocol should the driver use to interact with the commodity servers? And because I wanted to avoid reinventing the wheel with yet another configuration protocol, I decided to use some available functionality in ONOS by using the REST southbound protocol. This is a very simple and intuitive way of passing instructions to a server and getting information from a server, although I believe that maybe netconf would be a better fit for our task. The reason that I chose the REST southbound is that it provides a bidirectional channel to ONOS, while I couldn't really find a netconf server in ONOS. So please correct me if I'm wrong. And for the proposed driver, we also provide some extensions for the REST southbound device and device description classes of ONOS, which allow to provide additional information about the network cards and the CPUs. So regarding the behaviors of this driver, the current implementation covers 3 existing behaviors, which are a devices discovery, device description discovery, and port statistics discovery. And I also implemented a new behavior which collects CPU statistics from all the available processors of the underlying device. Initially, basically, I wanted to extend the device provider service of ONOS with methods such as update CPUs and update CPU statistics. However, I think this is not a very prevalent functionality to be part of the core of ONOS. So what I did instead is I decided to write an overlay application that is able to discover these statistics by itself without modifying the need to modify the core of ONOS. So moving to the next slide, there are also some missing behaviors currently in this driver, and the very first one is link discovery. So I found basically that the REST southbound itself is not currently supporting this behavior, but even if it could support it, it's still quite hard to implement such a behavior on a commodity server because it requires a way to basically formalize how packet in and packet out events can happen. And to enable such a functionality on a commodity server, we need a processing pipeline, as I said before. So we need a way, for example, to do LLDP packet injection from the controller and gather these packets back and discover the links dynamically and so on. So maybe, I don't know, if this slide is correct, okay. If it's not, maybe you can give me some ideas at the end of this talk how, if I haven't seen something in ONOS and I missed something, I could basically improve upon it.
Okay, sure.
So the way that we are, okay, maybe we can take the questions after my talk or whatever you prefer. I don't really care. We can even discuss now if you want to.
Yeah, I was simply acknowledging that we can get back to it later. That's all. I think because of the lag, it came across scrambled probably. So
Okay.
please go ahead. Please go ahead. This is good.
Okay, thanks. To address this problem with link discovery, basically what we have is basically a bit ugly workaround, in my opinion. We have an implementation that currently relies on the northbound REST API of ONOS, which is listening for events, and we can push such an event, a link event basically, that instructs ONOS how to connect to different devices. And in this particular example, I have created a link between an OpenFlow switch and a port in a server. And by this means, we can have like a link discovery application in ONOS that can take this kind of event and add it into the system. The second missing behavior, which is also very crucial, is the pipeliner behavior. And I borrowed this term from the OpenFlow terminology in ONOS. So although in this talk I'm talking about click pipelines, which is a way to instruct the general purpose CPU to perform a task, the principles are actually the same with OpenFlow pipelines or other kind of pipelines like P4. So also this behavior is not currently supported by the REST southbound. So to work around this problem, we decided to move this functionality outside of the driver by developing an overlay application, which is able to read from the northbound API of ONOS click pipelines, then compile and communicate these pipelines through the REST protocol. And this is a functionality, as I said before, that sits outside of the driver. Now, if I go to the server side of the implementation, so at the bottom part of this figure, I just want to briefly mention that currently we have implemented the C++ module in FastClick, which is a high-performance variant of the Click modular router based on DPDK. And this is undertaking the functionality at the server side. Now let's briefly discuss about some future plans about this proposal and ways to basically improve the work. So for me, the way to go is basically, if you like this proposal and if you believe that this is relevant for ONOS, I would really love to see this driver as part of the official ONOS tree. But before that happens, several things need to be done. So first, I need to implement some testing modules basically for the driver. So I would like your opinion about two things basically. What would be the coverage of the test that you expect in ONOS, and maybe if you happen to recall a good driver that I can consult to get inspiration for testing. Although this is not super critical, I can do this work myself, and this is not really hard to do. Also, I would like to take advantage of this talk, get your feedback, discuss, and come back to you with an enhanced version of the driver, which basically addresses some of your comments and concerns. Some other future extensions that could be added as functionality in the current driver is, for example, how do we incorporate memory components such as DRAM or cache as devices in a server. Also, there are some low-level abstractions provided by DPDK, which basically tackle some tasks that modern network cards can do, such as offloading. And as I said before, smart NICs is also a new exciting area where we can explore different other opportunities. So this proposal is part of a bigger idea, and basically, if you want more details of this idea, I encourage you in the future to check out our upcoming Usenix NSDI paper, which is called Metron, and it's basically a service chaining platform that operates at the true speed of the underlying hardware, which is commodity servers in this case. So with this, I would like to conclude this talk, and thank you very much for your attention. And I'm happy to take any questions that you have.
Oh, this is great. So I had just a couple of, I guess, questions and maybe observations. So
Yeah.
First of all, I think with you mentioned that there was no way to inject LDP packets or receive LDP packets on a server side from in terms of be able to instruct the NIC to be able to emit them, and there was no framework for receiving them from on a controller side. Is that correct?
Yeah. The point here is that for me, it was quite hard to be able to describe what a packet in and a packet out event would be for a commodity server.
Right.
This is easy to do for an OpenFlow switch, for example, but for a commodity server, it requires several assumptions to do so.
Right. So Mike, I guess so that clears it up. The reason I was asking that question is, I presume the primary reason why you would want to do that was so that the server could participate in link discovery process. Is that correct?
Exactly. I wanted this process to become automated.
I see. So the thing is, so it's the LLDP or the BDDP, whatever we want to call it. It's kind of the open flow discovery protocol, which is based on injecting and sniffing LLDP packets of the network. That's strictly not required to. I mean, it's clearly one of the dominant link discovery mechanisms that we have in ONOS, because that's something that works well with OpenFlow switches. But it's strictly not required at all, because you could discover links or relationships between various network components through entirely other means, which are not really that particular discovery mechanism is not at all prescribed.
Okay.
And so if you had, for example, some agent side software on a server itself, which I presume you have to have some server side agentry anyway, right? In order to be able to drive the functionality of the NICs. Well, you could obtain the information using some other means, perhaps even native means on the server itself, and then just simply report the information on the discovered components, whether they're links or various server-side resources, back to the controller.
By this, you mean that I could potentially, for example, post something to the northbound API of ONOS, right?
Well, so it's
from the server side.
Exactly. Now the thing is, which is south and which is north here is kind of gets twisted, right? Because effectively, what we're talking about is having a provider on a side which is capable of supplying the core with information about the links that are discovered in the environment.
Okay.
Clearly, that we're talking about the ONOS side entity, a piece of software, but that ONOS side piece of software can work with other external entities, from which it can either pull which can get pushed information about those links. So it's the protocol here is completely secondary, whether it gets it through REST, whether it,
Okay.
because that would be something that would then be kind of pushed to the northbound, as you said. But even if the information comes from northbound, the source of the information is external, and it just simply supplies information to the ONOS core about what those links are. And we effectively have one such component. I think it's called network config links provider or something like that, through which you can actually inject information into ONOS about which links there are out there, and whether or not ONOS can then engage in verifying the authenticity of those links through LDP or not, I think can be configured. That may not be 100% correct, but even if it isn't regarding the existing functionality that ONOS has, it would be really easy to derive a version which basically just accepts the information on good faith about those links out there, or perhaps has other means of validating that those links are valid. So
okay, that's good news.
Yeah, so I think using the LDP packet injection and sniffing is something that can be completely circumvented.
Okay.
So that's one thing. So the second thing, as you alluded to, some abstractions, introducing abstractions to ONOS in order to be able to talk about some of the server-side entities. And so currently with ONOS, the model is a little bit kind of the mental model of the network is a little bit simplified with respect to hosts, right? Because we even when we talk about hosts, we're really talking about NICs. And as a matter of fact, we actually are talking about NIC ports. It's basically just an interface. We do have support for dual homing hosts, which was recently added. I think Charles added it. So we do have some means of modeling the fact that hosts can be attached to multiple Ethernet switches at the same time. So I wonder if at least that enhancement could be used to represent the NICs. Whether it's going to be good enough for you or not, I don't know. That's something you'll have to take a look at. But I would look at the multi-homing enhancement that was added in the later versions of ONOS. I think it was with Magpie. It was introduced there.
Do you happen to recall the name of the driver that achieves this functionality?
So I'm not sure whether it's actually just a driver alone. I think it's just enhancements of the model itself with respect to how the information about the host location is stored. What I mean by host location is where the host is attached to the network. So and the driver for it, I don't think there's specifically a driver. I think modify the host provider. Which relies on ARP messages.
And as you said, the only functionality in this case is only the network interface card, right?
Effectively, right. But there's clearly in your list there would be additional abstractions that you would need in order to tie those to the host, and so that you can track them, like CPUs and potentially call out the NICs by their entity itself. So
yeah, okay, I'll check it out. Thanks.
Is there, I don't want to hog the mic here. Is there any other questions from the community out there? Quick question maybe for Carmelo. Do you see any relationship between the... Go ahead, Yuda. Go ahead. Sorry.
Yeah, I had one comment. So I think somewhere in the slide you suggested adding CPU statistic to the device provider and so on kind of things. But have you explored the idea, like, there are already existing systems like Graphite, Ganglia, Panda DCA, that kind of things that generally gather statistical information, which probably includes CPU and memory information. So another approach could have been that ONOS talk to those kind of data collections system and get the feed about that server from it.
I see. Right. So I think a few months ago, I posted a similar question in the list. And there was a response very similar to what you just said, that there are existing frameworks that basically are able to store this kind of information. And I looked particularly into the CP-man application. I don't know the full name of this. It's one of these applications that basically gathers these statistics. And what I found there is the ability to monitor a CPU of a system as a single metric. In my case, I was mostly interested in basically managing and monitoring a set of CPUs available in a system. So I wanted detailed load statistics from each core of a host, not just a single CPU metric, which was exposed by that application. So this is why I decided basically to write my own custom extensions in this driver. However, I want to clarify one thing. As I said in that slide, I'm not actually implementing this functionality inside the core of ONOS right now. This is something that is deliberately put into the driver, and it's completely external to the core. I would definitely like to check out all these other applications that you just said. Maybe I would be able to find some commonalities and maybe ways to integrate my functionality there. Of course, I'm all open to this.
So one note to add to this. The CP-man application stands for Control Plane Manager, and I think the primary objective of that application was to provide load information for the controller nodes themselves, so that we could monitor the machines which are running the distributed controller and use the loading information to properly distribute additional kind of workloads onto those controller nodes. So for example, it would assist in determining mastership and other things like that. And the whole point is kind of to monitor the well-being of the controller cluster from a physical kind of low-level sense. So I think in your case, you're talking about actually monitoring hosts kind of that are out there on a network, and which could potentially, in extended sense, could be considered part of the network resources.
Yeah.
Right. And so that's
a little bit. Just imagine a server with 4 CPU cores.
Correct.
Maybe ONOS is able to install 4 different pipelines, 1 per core, and then get statistics from these pipelines individually per core. This is why I wanted this finer granularity in monitoring.
Sure, and I think the CP-man kind of focuses on a specific narrow sets of metrics which are really useful only in the context of monitoring the server, kind of the controller itself. In your case, clearly, you might be interested in acquiring information about wider sets. But I think the basis of Yuta's question was to make sure that rather than reinventing the wheel from ground up, we take advantage of these technologies. Clearly, how the data is brought in on behalf of this particular application would be a little bit different, right? Because the data would be used in different purpose. So, yeah.
Okay, thanks for the clarification.
So yeah, you also mentioned something about P4. I was going to ask a question to Carmelo, but he had to drop off for another meeting, so we can perhaps hold that. There is a effort right now within ONOS to kind of exploit the P4 capabilities with the notion of this pipeline independent abstractions and pipeline ability to configure pipelines. And so I was wondering if there is potentially some possibility for leverage, because you effective with respect to controlling the flow of data through the smart NIC, controlling the activity of the smart NIC, and potentially also a little bit broader how the information is dispatched from the NIC to the CPU. I wonder if that could also benefit a little bit from using the similar concepts. But
definitely, this is why I mentioned before, because I know that it's basically protocol independent, and you can basically specify arbitrary functionality in P4, as far as I know. So this fits way better than OpenFlow into my proposal.
Right. So for that conversation between Carmel and you, we'll probably have to wait then, because he had to run off.
Yeah, sure.
So this is...
Hello, this is Andrea from Italy. Can you guys hear me?
yes.
I hear a lot of echo.
Okay, so I had a question. You mentioned that the pipeliner was not really hooked up into the REST southbound. May I ask why? In the sense that the pipeliner does not really interact with the southbound itself, but it actually uses then the flow rule provider, and sorry, the flow rule manager to install rules. So I didn't catch that part. Also, there are a couple of other places you mentioned that the REST southbound provider document those, so I can have maybe a look and see what can be interesting to put in.
Right. So let me rephrase what you just said, because I'm not really hearing very well. So you said that there is a rule provider in ONOS which can be connected somehow with a REST southbound and provide this functionality, right?
Yeah, the idea is that the pipeliner is not directly interacting with the REST provider, but it actually uses flow rule manager. And maybe if you're not hearing me clearly, Tom, you can explain this.
Yeah. I think Andrea's point was that the pipeliners usually operate at a higher level of abstraction. They're kind of protocol independent, meaning in a slightly different sense, in the sense that they don't talk directly to the devices, but rather what they do is they translate the higher level flow objectives into flow rules, and so they end up interacting with flow rule subsystem and group subsystem and other subsystems in ONOS rather than directly talking with the devices. It would be then the lower level drivers, such as the flow rule programmable driver, that would be then used to directly talk using a specific control protocol to the network elements. So,
right.
so the pipeliner here ought to be viewed as a high level, kind of more of a logical driver, which simply says how flow objectives break down into flow rules in a table pipeline specific way.
But if I understand this correctly, if I were able to implement for my use case, this shouldn't go through the REST southbound protocol. It should go through a different means, right?
Well, basically today the pipeliner would simply just say, okay, this is a flow objective, and this flow objective needs to translate into these flow rules, and then I'm gonna basically then program these flow rules. That's what the pipeliner drivers do.
The only reason that I mentioned that REST southbound is not providing this functionality, because you need a different channel for this, right? And I have another question here.
Yeah.
Is this pipeliner...
Sorry, it's not really another channel. We do have a mechanism for you to actually use REST to provide sort of a match action to the flow rule programmable.
Okay.
It's the same one we use for Metron.
Yeah.
If you want, we can take discussion line maybe, and I can show you kind of what the flow of that is.
Okay, that would be great, actually. Yeah, I didn't really catch this capability. Sorry. So yeah, maybe we can discuss offline and see which way this could be done more easily.
Yep.
Definitely. If you can start an email thread after the PSC, that would be great.
I don't really hear you very well. I'm sorry.
It is hard to hear you, Andrea.
Sorry, guys. I was just saying that if you could start an email thread after the PSC, that would be great.
A new thread in the discussion forum. Okay, perfect.
Yeah.
I have another question regarding this topic. So you said about flow rules and flow objectives. Is P4 going through the same manager for installing P4 commands, for example? I just want to understand the level of abstraction of this functionality.
Yeah, so it's probably a little bit of a longer discussion. It would be good to have a conversation with Carmelo, which is precisely why I intended to ask him that question.
All right.
Okay. There's a high level abstraction which is somewhat it's a little bit more flexible than what's today provided by the flow objectives. There is definitely a way to translate the flow objectives and flow rules into this, but the kind of the pipeline configuration protocol, or abstraction is a little bit to the side, and I don't know this so well enough to be able to. I think it'd be best if you talk with Carmelo directly, because this is something that has undergone a number of different mutations, and I haven't been keeping track of it full time. So definitely talk to Carmelo about this, because I think there's an opportunity to potentially leverage some of the concepts, because we're effectively talking about shaping the pipeline and then using the pipeline. Both the whole idea is to be able to use the pipeline both from a protocol agnostic view or pipeline agnostic view, using the flow objectives and kind of vanilla concepts like that. But in order to fully exploit the pipeline, you have to have an application that understands the pipeline and can actually program against the capabilities of the pipeline. And so there's this dual use mode, both pipeline agnostic and pipeline aware, that an application can engage with. The agnostic part is done through flow objectives, and it's the pipeline aware one where you probably ought to talk more with Carmelo to get more information.
Got it.
Yeah. Is there any other questions from the floor? If not, I had some logistical questions. Okay, so in terms of logistics, do you is there any? So there's the okay. Let me gather my thoughts here. So clearly, in order to be able to interact with the server, right? So there, you mentioned that there was some server-side components to this, which clearly would be. You mentioned they're C++, so clearly there would be platform specific, and they most likely would.
Yeah, there's a C++ implementation in Fastly.
Right. So that's probably something that would have to be kept outside of ONOS, or at least could still clearly would be something that might have to be referenced as a one possible implementation of an agent side or side functionality. And then there's the ONOS specific components, and I presume those are all platform agnostic and all written 100% in Java. Is that correct?
Yes, this is correct.
Okay. Because we've had contributions in the past that required use of shared libraries, which was
there's no.
Right.
It's all native. It's all native.
Great. So that's good. That's good. So my suggestion would be to start with as you start contributing this to the ONOS code base. So start with some of the foundational abstractions and interfaces, and so that those can get reviewed, and you can get suggestions, and you can make sure that those things are covered. I presume when you talked about adding test coverage, you were talking about unit test coverage, correct?
Sorry, can you repeat the question, please?
Unit. When you mentioned in your one of your slides was that what's still missing to be done is to have some test coverage done.
Right, the unit testing, right?
Yeah. Okay. So you were talking about unit tests, because that's something that we currently measure we measure only unit test coverage. We don't currently really have any, at least in a developer accessible test, we don't have anything that measures coverage using integration or system tests.
Okay.
So it would be good to have unit tests for things.
Right. Yeah, I'm planning to do it as soon as possible, so that should definitely happen in the next few days.
Great. Yeah, that's good, because that's something that we're asking. We're starting to ask.
So I have also one comment about what you just said. Please go ahead. I'll continue later.
No, go ahead. Go ahead.
Okay, I just wanted to ask about, you said about uploading some code, some preliminary code to review and start the discussion. Basically, my intention is to share with ONOS at first place the abstractions related to how we are able to communicate with the server and get network interface card and CPU information from that server. So it's a very preliminary version. It's basically a portion of the functionality of the whole project, which is dealing with the communication part with the server and the monitoring part. So this is what I was basically intending to provide as a first contribution. And then if the discussions proceed and we have good progress on how to better specify a pipeline and ability to install pipeliners and so on, then I could potentially extend and upload more and more functionality.
That's perfectly fine. That was going to be my suggestion, right? That it's done in pieces, and kind of start with some of the foundational ones. You know, what clearly there's different ways one can slice it, and as to what would be foundational. But I think if you want to start with doing some of the protocol specific utilities and from some kind of representational concepts and classes that would represent the server or some of its resources, that's where I would start. Yep, that sounds perfectly reasonable to me. Right. I just wanted to make sure that you were not, intending just to put one big drop, because while that's certainly possible to do as well, it's generally then much more problematic to review, and also requires kind of a lot of
yeah, I know it's a lot of burden for the reviewers.
Well, it's not necessarily just a question about burden, but also kind of understandability, right? So this is, if it's kind of eased in terms of you kind of almost along the dependency chain, right? Because you can understand the reviewer can grasp some of the low-level independent pieces without having to be first exposed to the entire thing, right?
Right. Yeah, I agree.
Brings it in along the lines of dependencies, so that would be good, and that'll simplify the reviewing process for everybody, I think.
Yeah, we are totally in line on this. So
great. Well, this was really useful. This sounds like a very interesting use of ONOS and how to kind of extend the modeling domain of what ONOS is concerned about, and so that it can reach into the server land, so to speak. Do you have? Would you be able to provide me with this presentation? You don't mind if I post it as a reference on our Google Drive?
Yeah, I can. I have the slides as a Google document, as a Google presentation, so I can give you a link after the talk. After
perfect.
The meeting.
That would be great. Yes.
Yeah.
All right. Is there any other questions from our audience, or do you have any other comments, Georgios?
So just a comment. I'm really happy that this is coming together. It's something that we started discussing a long time ago, and finally it's getting back into the ONOS code base. So this is great. Thanks for the contribution, Georgios.
Yeah, thanks, Andrea. Actually, you were the first to listen about this project and give me feedback. So I really appreciate this and your travel here in Stockholm to present ONOS. So it finally came true to contribute something in the community. Thank you.
That's great. Glad to hear that. All right.
I guess we take all the discussions in the thread, right? In the list.
Yes, I would definitely encourage that, and both through the Gerrit review and through the mailing list, we should be able to hopefully continue this. And don't hesitate to reach out directly if you get stuck somewhere. Okay.
Okay. Thank you very much for your attention and comments. Really appreciate it.
Great. No, thank you for spending time to prepare this and give this talk. Thanks.
Thanks.
Talk to you later.
Thank you.
Bye-bye.
Bye.
Bye-bye.